going to go ahead and turn to our next presenter, who is Stephen Keller. He'll be giving a presentation entitled Language, Code, and Translation. And I'll go ahead and turn the floor over to you, Stephen, now.
Okay. Hi, everyone, and thank you, Cecily. Switch over here. And okay, that's okay. So hi, everyone, again, and I'm very happy to be here with all of you. And I would like to start this presentation by briefly discussing what a computer language is. Computer programs are made of algorithms, and in the book Software Studies, a Lexicon, the chapter entitled Source Code by Krisa and Sedek defines algorithms as a set of defined formal procedures to be performed in order to accomplish a task in a finite number of steps, which is similar to a cooking recipe. A computer language is what is used to implement an algorithm into a computer program or software. Computer languages are further divided into low and high level. My focus here will be on high level language, those that use higher level abstractions that humans can understand and use when writing a computer program, as opposed to the more direct way that low level languages are used to access and control computer hardware and its operations. To help exemplify the reflections I want to make in this presentation, I wrote a Python code that was then translated to JavaScript. To keep things simple, the program is a Hello World code with some twists and turns. Hello World is one of the first things many programmers will learn and simply shows the words Hello World on the screen. It is a simple set of instructions given to the computer, but here the set of instructions are unnecessarily tedious and complex. The program follows the steps shown in this slide. It starts by assigning hello and world into variables and creating two containers. Then it adds together the variables, check if the result is a string of characters, and if so, returns it. That value is assigned to a new variable and a new check is made. If the stored value is equal to the sum of the two initial variables, then it is stored into the first container. A new series of checks are made, and each time the check is successful, an instance of Hello World is added to the second container. Finally, the program gets rid of any duplicated entry in the container and prints the remaining unique Hello World. If these instructions sounded confusing, this is exactly the point of the program. The image here shows the Python code and the program being executed on, on the operating system console. The words Hello World are in between curly brackets, indicating that they are a string of characters inside a container, or list, as they are called in Python. At this point, I would like to make a distinction between the more general genre of electronic poetry, or e-poetry, as it's sometimes called, and code works, a term coined by the electronic artist and poet Alan Sondheim. In many cases, we could say that the poetics of e-poetry arise at the moment of the execution of the algorithms that were used to generate the poem. In code works, the code itself is the artistic medium. In my example code for this presentation, what I attempted to do was use code to create a very simple code poem to express the complexity, bureaucracy, and repetition of many processes that could be done otherwise in a quick and simple way, and that we have to endure constantly as humans. It's the opposite of what a computer programmer would normally aim to achieve, which is a clean and efficient code that gets the job done in a few lines of code as possible. Also, to run and interpret the code, the reader would need some computer knowledge. A computer with at least a basic version of Python installed so the code can be run from the command line, and also the ability to understand the code and why it is an inefficient way of writing a simple Hello World program. We are now seeing the same code translated to JavaScript. All of the steps are still present and in the same order, and most of the syntax is very similar. A couple of functions needed to be adapted to the specifics of the new language. Since computer language deals with instructions given to the computer, when we translate from one language to another, we need to make sure the instructions or the program recipe are kept intact. The code logic should stay the same if you want to run the same program in another computer language. Computer language are interfaces used by humans to communicate with the machine. Different languages serve different purposes and might be more or less useful to different applications and programmers. But in the end, all high-level computer languages, such as Python and JavaScript, will be translated into a language that the computer hardware can actually understand. When we humans write a computer program, we are not talking directly to the machine and its logic. We are not giving direct orders on what calculations to perform and what values should be assigned where in the computer memory. High-level computer languages are abstractions of constructs that we can understand as humans. We write code using human logic. Code logic is human logic until it is compiled into a low-level computer language. And it is this human logic, disguised as code, that is translated when a program is translated from one programming language to another. Human language is embedded in and with meaning, and so is computer code. Going back to your example code, it was written to print a simple string of characters using a long set of instructions. Those instructions are not visible unless the reader reads the file containing the computer program or source code, and the actual meaning of it won't be available unless the reader checks it. The invisibility is part of the meaning of this Hello World program that I'm bringing here. When the program is now executed on a web browser, nothing is immediately visible on the screen. The HTML code is simply importing the JavaScript code and running it once the web page is loaded. To see the message, the reader needs to open the developer tools on the browser, go to the console and see what is printed there. It shows Hello World inside curly brackets, again indicating that the string of characters is inside a container. And here is where an adaptation was needed for the original meaning and intent of the program to be kept when it was run in a browser. The Hello World message is still hidden behind a layer of computer literacy, and the JavaScript code is available for viewing from the browser developers too, should the reader wish to check what is actually going on that page. But different mediums offer different translation opportunities. A web browser is a much more evolved platform than an operating system console window. The JavaScript and HTML code can be adapted to show the Hello World message in the browser itself. By not hiding the message anymore in the browser console, the meaning has now changed. And the browser can also allow for other types of interactions with the reader. Here we see the Hello World message in a pop-up window that is shown once the page is loaded. Such changes in meaning and interactivity open up opportunities for code transcreation. Because Hello World is now being shown in the browser directly, people who wouldn't otherwise open the developer tools or even know that the developer tools exist now have the ability to read the Hello World message. The code translator would need to look for strategies to convey the meaning of the code to this new audience. But how would an audience with no computer programming literacy understand the meaning of a code work? And what about medium and computer language specific types of interactivity and functionalities that may not be available outside of the original context a program was designed in and for? I don't have answers for these issues that require creative transcreation solutions, but these are questions and reflections I'd like to offer to anyone interested in the process of media and electronic poetry translation, preservation, and restoration, as computer languages become obsolete and are replaced by others, and digital tools and technology continue to evolve and change. And yeah, that was my presentation, and thank you very much.
Thank you so much, Stephen. I forgot to also introduce you. Stephen is a master's student in digital humanities in our ad hoc program, and I have the pleasure of working with him as well.